Alright, Algebra 2, here are the notes for cubic functions and solving them. Alright, now next year you're going to see different ways of factoring. So for this one, we're just going to focus on factoring by grouping, our difference of squares over here, our sum of cubes, and then our difference of cubes as well. And then also don't forget to factor out the greatest common factor for the first step. Once you factor it, you're going to set each term to 0, and that's when you're going to actually start to solve these problems. So when we're talking about a root, these are things we've already talked about. A root of an equation is the solution of the equation. A 0 of a polynomial p of x is the value of x real or complex, which makes p of x 0. So if we were to substitute that value back in, the entire equation is going to be 0 because it means that it's crossing the x-axis. Okay, so if p of x is to the nth degree polynomial, then p of x has exactly n linear factors. And they may be real or complex. So when we talk about complex, there could be imaginary numbers in that situation. This year you're not going to see that too much, but next year you may. All right, so let's go ahead and take a look at A. Now with A, we're going to go ahead and start by factoring. So when we factor, I notice looking at A, there is a greatest common factor that we can go ahead and factor out. That greatest common factor is x, because both terms have x. So I'm going to go ahead and factor that out to the front. What's left over is x squared minus 4. Alright, now x squared minus 4 is actually a difference of squares equation up here. So what we're going to do is we're going to go ahead and we can rewrite this as x squared minus 2 squared, and that would be our a and b. Our greatest common factor still stays out. I'm going to bring that down one more time, and I'm going to go ahead and factor out this difference of square going on. So that's going to be x plus 2 and x minus 2. Now at this point, our equation would be y equals x times x plus 2. Oh, sorry guys. X minus 2. And what we would do now is we would set each one of those equal to 0. So we would start off with x equals 0. That's one of our solutions. Okay, our next one would be x plus 2 equals 0 and x minus 2 equals 0. In order to solve for x, we would subtract the 2 to the other side on this second one. So that would just mean that x is negative 2 and x equals positive 2. And what that truly means on the graph is, here's our x-axis, here's our y-axis. We really only care about this x-axis at this moment for the solutions. It's going to cross at 0, and it's also going to cross at positive 2 and negative 2. So those are going to be the three solutions. All right, but this is as far as you really need to go. So you would just state that x equals negative 2, 0, and then positive 2. There you go. All right, so let's take a look at B. So with B, we're going to start off by looking to see if there's a greatest common factor, which I notice that all three terms have x. So I bring that down. So I'd have x squared plus x minus 2. All right. Now the second thing I have to do is look at this trinomial inside to see if we can factor it. And in this case, because a is 1, we can go ahead and take a look and see. We would end up with, what are the factors of negative 2 that multiply to give us negative 2 but add up to give us positive 1? And that's going to just end up being 2 and 1, but we need a positive 2 and a negative 1 in order for that to subtract out to just positive 1. Now we have our three terms. We're going to go ahead and set each one of those equal to 0. So we have x equals 0, x equals negative 2, and x equals 1. So those would be our three zeros on the graph. So you can go ahead and write it in domain form. So we would state that the answer would be x equals negative 2, 0, 1. That way it's kind of in order. And then you're all set for B. So let's go ahead and take a look at C. Now, if you notice C, there's nothing to factor out anymore. They actually give you the terms. So we can go ahead and set each of those equal to 0. So we have 3x minus 4 equals 0, and then also x minus 4 equals 0. The last one and the first one are easy to figure out. X equals 0, and this one would be x equals positive 4. This one we do have to add the 4 over, and then we would have 3x equals 4, divide both sides by 3, and we would end up with x equals 4/3. Okay, and you can leave it as an improper fraction. All right, now I'm going to organize these from least to greatest. So it would end up being x equals 0, 4/3, and 4. All right, let's go ahead and take a look at D. Now with D, I noticed there are 4 terms. And I noticed that there's nothing we can factor out of all 4 terms. So what we're going to do on this problem is we're actually going to go ahead and factor by grouping. So I'm going to go ahead and take a look to see what can I factor out of the first 2 terms. And in this case, I can factor out an x squared. And then what would be left over would just be x plus 1. Now on the other side, we're going to go ahead and factor out a negative 4. So that would leave us, after we divide out a negative 4, that would leave us with x plus 1. All right, now what we're going to do is we're going to go ahead and take a look at the fact that we have x plus 1 on both sides. So we're going to factor that out to the front, and we're left with x squared minus 4. Okay, so we're not finished on this one though yet, because x plus 1, that works. That's great. There's nothing else we can factor out. But I notice on the second term, I have 2 squares. Okay, so what we're going to do is we're going to go ahead, and it's a difference of squares. So we're going to go ahead and factor that out. That's going to end up being x minus 4, oh, not 4, x minus 2, and x plus 2. And then in the front, we would x plus 1. So now what we're going to do is we're going to go ahead and set each of these terms equal to 0. So then we would have x plus 1 equals 0, x minus 2 equals 0, and x plus 2 equals 0. Okay, on this one we would subtract the 1, so it would just be x equals negative 1, x equals positive 2, and x equals negative 2. So looking at our solutions from least to greatest, we would have negative 2, negative 1, and positive 2. When we're all set. All right, now we're only going to have one last problem. I erased F because it had a way of factoring that I didn't show you guys. You'll see it next year in pre-cal, but this will get you going. So we have this last problem. I wrote it down here because I noticed that I didn't save it on the same page, so I'm just going to go and scroll that up. Now, we're given 4 terms. There's nothing I can do with as far as difference of squares, sum of cubes, difference of cubes. There's no greatest common factor I can factor out. So what I'm going to do now is, because it's 4 terms, we're going to go ahead and use factor by grouping. Now, so I can go ahead and split the middle and see what factors I can come out of the first 2 terms. And in this case, it's x squared. So what's left on the inside is x plus 5. And then on this side, I noticed that both terms are negative, so it's going to end up being a negative, but there's really nothing else that can be factored out. But you can always factor a 1. So then, what would be left over is x plus 5. Okay, and now what I notice is on both sides, we can go ahead and factor out an x plus 5 from both sides. And then goodness gracious, we would be left with x squared minus 1. Now with x squared minus 1, we can go ahead and factor that further. It would be a difference of squares in this case. So we can go ahead and we would have x minus 1 and x plus 1. Bring down that x plus 5 in the front. So now that we have that, we're going to go ahead and set each one of these equal to 0. So we'd have x plus 5 equals 0, x minus 1, don't know what I was doing there, equals 0, and x plus 1 equals 0. Okay, so our solutions would be x equals negative 5, x equals 1, and x equals negative 1. Go ahead and write these in order from -5, -1 to +1. And there you go. That's how you would find the solutions of the graph. And truly what you're finding is with this polynomial is crossing the x-axis at these 3 points. So we end up having a solution at -5, 1, 2, 3, 4, 5, -1, and +1. Okay, we know the graph is going to cross at those 3 points. Now, because we have this part right here, where it's in factored form, in a recent lesson, I think it was lesson 2, we talked about what the polynomial behavior is happening at the x-axis when it's to the first power, second power, and third power. And so when it's to the first power, that's just a cross, kind of like a linear equation. The second one, squared, is tangent. That's where it's gonna, this is gonna cross. And tangent is where it's gonna bounce. And if it's to the third, that would be a point of inflection. Whee! Kind of like a wiggly worm. Alright, now, so this graph, remember, because it is positive, that's going to tell us that the right side is going to be positive to positive infinity as our end graph. Now it is odd, so because it's odd, I know that the end behaviors are not going to be the same. So it's actually going to start off in the negative direction over here from -infinity to +infinity. Okay, so what we're going to do now is I also know at this point, go away, at this point it's going to be a cross. This is also going to be a cross. And this is going to cross. So we're going to start off at the -infinity part, cross, come up, go down, cross, cross, and then we're going to end in infinity. Now, as far as how far up or how far down we're going for a maximum relative min, we don't know that information. And this year we're just locating what the zeros are or what the solutions are of the equation. That's what we're truly focusing on. So now that's about it. This lesson was really just to find the zeros, which is this part. And then we're going to review, or you're going to review, all of these different behaviors going on with the polynomial. All right. I hope you guys are doing well, and please let me know if I can help you in any way. Please email me if you need help. Otherwise, have a wonderful day and the rest of your week.